In today's class, we have a Millman's theorem. So let me explain Millman's theorem using one example. Before that, I will just give you the statement of the Millman's theorem. So Millman's theorem states that if n voltage sources n, so in this we have three. If n voltage sources, suppose V1, V2, so on to Vn, having internal impedances are series impedances, suppose Z1, Z2, so on to Zn respectively, are in parallel, then these sources may be replaced by a single voltage source of voltage Vm and having a series impedance Zn. You can draw like this, so it will be something look like this. This is single voltage source and a single impedance A, B. This all the sources are converted into the single one. Let us look for this example to understand more clearly the theorem. We are given with the voltages 3 and impedance 3. We have a load impedance 10. To calculate this, we have in this problem we are going to calculate the current through the 10 ohm resistance in the circuit. To calculate the current through the 10 ohm resistance, first what we have to do is we have to find out the value of impedances and voltages, Millman voltage and Millman. Then first you need to calculate the admittance. Y1 is nothing but the reciprocal of Z1 is 4. 1 by 4, the unit is mho. And Y2 is 1 by 12 mho. Y3 is, we have 1 by 5 mho. So that's the reciprocal of the impedance. So according to the Millman's theorem, we need to replace it with the equivalent voltage source and the impedance across the 10 ohm. So let us calculate first impedance. Zm is nothing but 1 divided by how many? Y1, Y2 and Y3 we have. So therefore we can write 1 by 4 plus 1 by 12 plus 1 by 5 are the admittance. If you calculate this value after taking the reciprocal, after finding the LCM and all calculation, you must get 1.875 ohm as the total impedance. Now calculate the voltage, single voltage, Vm. So Vm will be equal to, we have formula for the Millman's theorem, V1 Y1 plus V2 Y2 plus V3 Y3 divided by Y1 plus Y2 plus Y3. Just substitute all the values. V1 is 12, 12 into Y1 is 1 by 4 plus V2 is 48 into, we have 1 by 12 plus V3 22 into 1 by 5 divided by 1 by 4 plus 1 by 12 plus 1 by 5. Do the calculations using the calculator. You get Vm as 21.375. So we have got the value of Zm and the Vm, 1.875 as Zm and voltage as 21.375 volt. Now we have one more resistance, that is the 10 ohm across it. So we have converted this. You have to find the current through this resistance, which is I 10 ohm is equal to, so the voltage is Vm. I is equal to V by impedance, Vm divided by, we have the two resistances, one is the impedances and under 10 ohm resistance, Zm plus 10. So Vm is 21.375 volt divided by Zm is, we have 1.875 plus 10. If you find out the value, you will get 1.8 ampere. So this is how we find out the current in 10 ohm resistance, and this is the proof of the Millman's theorem also. Thank you for watching these videos. Please don't forget to subscribe and share our channel, and plus press the bell icon button. In the next class we will see some more theorem